Now let us see how the power system automation evolved in the past. So you can see that the uh, relay logic was first introduced in 1900, and it started with factory electrification, and then slowly it integrated with the power system network, and between 1900 and 1920 it underwent rapid adoption. Supervisory control and data acquisition system, which we commonly know as SCADA system, were installed in 1920, although the SCADA word was emerged in 1960. At the same time, some high voltage substations which were adjacent to the generating stations could be monitored and controlled from the power plant's control room with the help of the SCADA system which was available at that time and using the relay logics. In 1930, individual utilities started interconnecting the electrical grid so that they can reduce the operating cost. So you can see that in 1930 we already started the interconnection of the power system network. Now with this, it came to the need of better monitoring and control of the power generation, the tie line power flow, and frequency of the system using computers. So at that time we were having only analog computers, so we utilized that to have the better monitoring and control of the power system network. But that effort was very limited because the systems which we were using at that time were not having much capability. Now in 1950s, the analog computers started scheduling of the generation using economic dispatch, automatic generation control. So this gave rise to the advent of the energy management system, which we commonly know with the name as EMS. Now EMS was supported by offline manual calculations at that time for economic dispatch, and then negotiations were done between the utilities to set the tile and power flow schedules at that time. Prior to 1950, the predominant control systems which we were using were mostly analog and simply were on-off control because we were not having digital control capability. First digital control system was placed into operation in 1959 at the Port Arthur in Texas refinery. Now, in late 1960s, when the digital computers and softwares were introduced, then there were a lot of software applications started developing to replace the analog energy management system. So software applications were developed to include the offline analysis functions, mainly because of the limited processing capability of the computers of that time, along with the transmission system analysis and modeling. Now vendors at that time modified the computer suppliers operating systems to meet their design applications. The application software was usually unique for each customer. So you can see that the operating systems were not robust enough, and the computer suppliers operating system were comfortably modified and designed to suit the individual requirements. Thus, the frequent upgrade was required for entire systems, or you need to have the replacement of the entire system if you want to change the vendor. Now this trend continued until 1980s, and even towards the starting of 1990s, until we got the open standard operating system developed and the deployed in the system to support the real-time applications. So up to nearly 1990, it was common to find EMS system being delivered based on proprietary hardware and the operating systems. Since we were not having any open standard for energy management system, each vendor was free to develop his own proprietary protocol and run the EMS system. So when digital systems came into the existence, many vendors appeared, and but they stayed in the business only for a short time, which caused interoperability issue, because when they were in the business, they developed the system with their proprietary protocol. Now, when they are not in the business, there is no one who knows the protocol or the technology which they have deployed. So, if you want to add any new device or any new application, the data which was supposed to flow from one application to other application was not possible, because no one knew what kind of proprietary protocols were deployed. Now, in 1980s, there were around 6 to 8 shared protocol which lot of vendors used to have, but there were another 4 to 5 proprietary protocols which were with the utility specific applications. So you can say that these were utility specific protocol which were developed as a proprietary protocol. Now, when intelligent electronic devices began into the market, number of protocols exploded like a mushroom cloud. So now what happened? Each vendor invented his own proprietary protocol to gain the market. So in the market, we were having a lot of devices with the proprietary protocol, and the utilities company were facing challenges in integrating all those devices in the power system network, because the devices were not capable enough to talk to each other if the devices are coming from different vendors. So this gave a lot of pain to the utility companies to integrate the devices in the power system network. So this was very difficult for utilities as well as the vendors to integrate the IDs into power system as well as the control systems. Now 1982 was a breakthrough year for our network communication, because the RS-422 and RS-485 was developed as an open network protocol which was developed by Opto 22. So you can say that 1982 was the starting period of the network communication. Now in late 1980s, IEEE PS Substations Committee formed a working group to investigate the problem of interoperability, because at that time there were lot of protocols which were proprietary in nature, and it was very difficult for vendors and the utility companies to work with so many protocols. Then this committee was given a mandate to solve the interoperability and the device integration problem and determine the resolution. So that working groups selected finally the distribution network protocol version 3, that is called DNP3, and IC 60870-5-101 as the open standard protocol for SCADA communication, so that the vendors who integrate and the suppliers who supply the devices and the software can make sure that their solutions and the devices are compatible with DNP3 and 60870-5-101 protocol. So early utility control and monitoring systems were based on telephone technology, because at that time we were not having matured mobile communications. So most of the communication used to happen through telephones. So the normal speed which we get through telephone lines was around 300 bits per second, which we generally known as with the name of baud rate. So gradually we increased this baud rate up to 1200 bits per second and 9600 bits per second. But if you compare, the speed of the data communication at that time was very slow as compared to the today's communication network speed which we get. So you can see that the requirement for better data communication and the monitoring was still there, but we were not having associated technologies available to support the requirement. Now let's see how our computer network evolution happened. In 1970, the Advanced Research Project Agency network, which is known as ARPANET, was the first network to implement the protocol suite, that was TCP/IP, which was so basically this network project, which was started in 1970, was decommissioned in 1990, but this gave the concept of TCP/IP. Now Ethernet was commercially introduced and standardized in 1983, and which was commonly known as IEEE 802.3 standard. In 1981, TCP/IP was standardized for Internet, and we also known as IPv4. Now, first implementation of TCP/IP was in BSD Unix in 1989, and then in Windows 95. Later on in 1998, IPv6 was also proposed, because at that time we forecasted that the number of IP addresses we get in IPv4 will soon going to exhaust. Now you will be surprised to know that in 1985 we registered our first .com domain. In 1989, Tim Berners-Lee invented World Wide Web, which was available for commercial use for 1991. In 1999, IEEE 802.11b, which is wireless networking, was introduced, and if you see the mobile communication, we started with first generation in 1980s, second generation in late 1990s, and then we had 3G in year 2000s. So now you can see that we were having requirement of better power system automation from say 1900 itself, but the communication and the associated IT was not developed at that time. That's why the analog computers were used at that time, and most of the work was done offline, and the need for automation grown up when we started interconnection of the power system network, and later on when we started the proper use of SCADA and the energy management system, the demand for better monitoring and control happened. But the problem which we were having related to better monitoring and control was associated with the communication and the information technology matureness, because at that time these two technologies were at very nascent stage. So the power system automation and communication and information technologies, all three technologies developed in silos, and the integration of these three technologies could not happen effectively in the late 90s as well as in early 2000s. So now you can understand that how different technologies were evolved at different point of time, and now you can visualize that why there is a requirement to integrate these technologies in the power system network. So in the next video we will start our discussion about how smart grid evolved, and which act in the US gave rise to the word called smart grid.